Hi, and welcome to this session where we're going to work through curves in processing. As usual, for questions, go to Slido. You use C046 as the code for this one. So drawing shapes made of straight lines is easy as we've already seen. We can say begin shape and then give a series of vertexes, as many as we like in fact, and then call end shape, and that will join up the straight lines into a shape. But a lot of objects aren't made of straight lines. So we can draw lots of straight lines, or we can actually draw curves. Curves use mathematical formulas usually. So something like y equals x squared, or y equals x cubed. And that's not straightforward as far as specification goes, so we're going to work through that. So a quick example of what that might look like. Here we've got some code. This has a simple quadratic curve and a cubic curve here. So when I run this, it's very simple. It just draws a quadratic curve or a cubic curve. Now you'll notice setup, we set the line and the size here. We setting up how to draw the curve here. You can see this is a simple square, and this is a simple cube. So this is squaring the width divided by 2, and this is setting the scale of height divided by that maximum value there. Then we draw a series of vertexes with begin shape for each of them, and same here. That's how we work through drawing curves. Processing has 5 functions to draw curves. There's Bezier, curve, Bezier vertex, curve vertex, and quadratic vertex. So we're going to focus on the vertex functions today. Bezier and curve work much the same way, but use a slightly different syntax. So quadratic vertex uses a quadratic equation like this one that we've seen before. There's no inflection point. It's a very simple curve. There's no point where it inflects from the straight curve. You can see that's always curving. However, here we can see at this point it goes straight and then starts curving the other way. So that's the inflection point. Curve vertex and Bezier vertex use cubic equations, so they do have that inflection point. So here's a quick example of quadratic vertex. So we set the line, then we say begin shape. We set the first anchor point, the starting point, at 2020. Then we use quadratic vertex and we say the control point and a second anchor point, and end the shape. So let's have a look at that. So we're looking at quadratic vertex form. So here's a shape made with quadratic vertices. And here's an interactive example. So here, the control point allows us to move the control point. It's interactive. So you can see there's a starting point, a control point, and an end point, or vice versa. And the position of the control point determines the shape of that curve. Still doesn't have an inflection point though, notice. To create more complex forms, you can combine quadratic vertex calls. So here we've got two of them. And we can have a look at that. Here's a simple example. Now this is a very, very, very small example. Here we have begin shape 2020, and we've put an ellipse there to mark it. Then we have quadratic vertex 80, 20, 50, 50. So that's here in the middle, but the control point is over here. So 80, 20, 80 is x and 20 is y. So that's that point there. That's the control point, and then 50, 50 is the next vertex. Then we stick a rectangle there so you can see that. Then we go to ellipse and we put that at 50, 50 so you can see that. And then we have another quadratic vertex call with 20, 80. That's 20 x and 80 y, so that's there. And then 80, 80, so that's that one there. And then we have another rectangle and another ellipse. So that's showing you we have now got a inflection point, don't we? Because we've got that second vertex. So this is not a cubic form yet. We're doing a set of two quadratic curves. Now Bezier vertex has two control points. So we set up an initial anchor point, and then we have control point, and a final anchor point. So this involves just having one vertex, and one Bezier vertex involves having 4 points. The first vertex, control point, and final anchor point. Okay? So let's have a look at interactive Bezier vertex example. Show you the code. So here we have setup and draw. So we begin the shape here. We say the first vertex, which is this grey one here. And then the second one is Bezier vertex, control 1, control 2, and anchor. And as we move these around, you can see the different behavior here. These two control points give us quite a lot of flexibility. And notice we have this inflection point here in the middle, where it is straight and then it curves the other way. We can move the position of that point with our control points. Now here we have the curve vertex option, which is slightly different to the Bezier option. And here we have begin shape, and then we just have a number of vertices. So it's not as complicated as Bezier vertex, where you have two control points and the anchor point for each Bezier vertex you set up. Difference here is, if we look at this one, each of these curve vertices acts as a control point for the next you can see. So let's have a look at the code. Now you should work through this code in quite a good amount of detail, because a lot of things are going on. but it's relatively straightforward. A lot of this code is to make this example interactive. Most of the normal work that's going on that you'll need to copy is here. The begin shape, curve vertex, curve vertex, curve vertex, curve vertex, curve vertex, curve vertex, curve vertex. So that's anchor points with, there's 2 initial anchor points and there's 2 final anchor points. That's to stop the curve and make it not go round and round. And then curve vertices 1, 2, and 3 are only single values. Now notice we've got this little slider here. We can change how curvy we want our vertices. We can go curve in as well, so they can be loop-like vertices. Here we have the call that is used to do that. So by setting up a curve tightness with a particular value, you set the behavior of those vertices, and you control how curvy the curves are. So we can have a look at that directly with a very simple example without all the interactive control. Very short. You can see this is a straight call, so maybe you want to start with this when you're using your curve vertices. And here we have mouse X controlling the amount of curviness, the curve tightness. Here's tightness. We're mapping mouse X and 0 to, mouse X with 0 and width. So that's values that are inputs between 0 and width become outputs between -5 and 5. Map's actually a really useful function. Then we have a typical set of curve vertices. Notice we still have that double first and double last to stop it from curving around itself. And we control the curve tightness. This is animated just by redrawing. There's a background call there, so it clears the previous background. So hopefully you're now able to draw curves in processing. Use this knowledge to build more natural looking forms and animate the shape of forms. Curves are very important if you want things to be more than just triangles and squares and circles. Thanks very much.